Hey everyone, and welcome back to AI Podcast. It seems like every single day there's a new headline about AI doing something incredible,
It really does.
especially all those large language models.
Hmm.
The LLMs that are behind things like ChatGPT and Bard and
Mm.
Claude and so many others.
Right.
They can write and translate even code.
Yeah.
It's mind-boggling. But
Yeah.
here's the question that I've been thinking about a lot lately.
Okay.
Have we pushed these LLMs as far as they can go?
Mm.
Like, are we hitting some kind of ceiling with current technology?
Yeah, that's kind of the million-dollar question that a lot of us in the field are thinking about right now.
Really?
Yeah, there's been this race to build bigger and bigger models.
Oh, yeah, for sure. Like
Right.
GPT-4.
Right, exactly, like GPT-4 and Google's Gemini.
Yeah.
But it's starting to feel like we're hitting a point of diminishing returns.
Okay, so you're saying that just making these models bigger isn't magically making them smarter? Tell me more, like, what's happening behind the scenes.
Well, one of the things is that these massive models are just so resource intensive. Okay.
Training them requires crazy amounts of computing power and special hardware and energy.
Wow.
We're talking like a small town's worth of energy consumption just to train one of these things.
No way.
Yeah.
Yeah.
And then on top of that, finding enough good quality data to feed these data-hungry beasts is a whole other problem.
Oh, right, because you can only scrape so much of the internet, I guess.
Exactly. You run into these quality issues after a while.
Huh.
Yeah.
So is it not even just a question of, like, can we even do this?
Right.
But should we even be trying to build these behemoths?
Yeah.
Especially when it costs, like, tens of millions of dollars to train one?
Yeah.
Are we even seeing a return on that investment?
That's a huge debate right now.
I bet.
And it's not just theoretical either.
Oh, really?
Like OpenAI's Orion project, for example.
Okay.
It was supposed to be this huge leap forward, even bigger than GPT-4.
Right.
But it's been having some issues,
Oh, wow.
especially with coding tasks, which is kind of ironic.
Because that was supposed to be, like, one of its strengths. And then you've got Google.
Yeah.
They've been having some internal struggles with their Gemini software.
Really?
Yeah, and even Anthropic has delayed the release of their Claude 3.5 Opus model.
Wow. So even the companies that are leading this charge are hitting these roadblocks.
It seems that way, yeah.
That's such a surprising twist. I just thought more data always equaled a smarter model.
Yeah.
So what's causing these roadblocks, if it's not just about size?
Well, I think we're starting to bump up against the limitations of the current training techniques and the underlying architecture of these models.
Oh, yeah.
It's kind of like if you imagine trying to cram more and more books into a library,
Okay.
but you're not changing the way the shelves are built.
Yeah.
At some point, it just becomes so inefficient and chaotic.
Okay, so if just scaling up isn't the answer, then what are the alternatives? Like, where do we go from here?
Well, that's what has a lot of researchers so excited.
Yeah.
It's like we're at this crossroads, and instead of just one path forward, there are all these different exciting possibilities opening up.
I like it.
So one path is to focus on developing much more efficient training methods
Hey.
that use less compute power and less energy.
Yeah, this seems like a no-brainer,
Right.
given all the costs and the environmental concerns and stuff.
Exactly. And another really fascinating avenue is something called model fine-tuning.
Model fine-tuning.
So the idea here is to move away from trying to build one giant model that can do everything,
Oh, okay.
and instead to create specialized models that are really optimized for specific tasks.
I see.
So, for example, imagine an LLM that's specifically designed to analyze scientific papers, or one that's really good at generating marketing copy.
Uh-huh.
It's all about having the right tool for the job,
That makes sense.
rather than trying to use this one Swiss Army knife to do everything.
Yeah, like a jack of all trades, master of none type of thing.
Exactly.
I'm starting to see the picture here. So it's not just about the raw size of the model. It's about refining it and specializing these models to be more efficient and more effective at what they do.
You got it.
Okay. And there are even more radical approaches out there,
Oh, like what?
like hybrid architectures.
Hybrid architectures.
Yeah, that combine the best of different AI approaches.
Okay.
So things like symbolic reasoning, where AI uses logic and rules,
Uh-huh.
and neural networks,
Mm.
which are more like the human brain learning from patterns and data.
Okay.
These hybrids are still in their early stages, but they have the potential to overcome some of the limitations that we're seeing with current LLMs.
Interesting. And what about knowledge distillation?
Ah, yes, knowledge distillation.
Oh, love that.
That's where you basically take a smaller model and you have it learn from a larger, more complex one.
Uh-huh.
It's like an apprenticeship program for AI.
I love that.
The smaller model doesn't have the same vast capacity,
Right.
but it learns the most important techniques and becomes much more efficient. Cool. So are we seeing a potential shift in focus then from building bigger models to building smarter, more specialized ones?
I think so.
So it's not about like the horsepower under the hood anymore, but it's about optimizing the engine for a specific type of race.
That's a great analogy.
Thanks.
And the exciting thing is we're already seeing some success with this approach.
Really?
Yeah, think about GPT-3's specialized variants.
Okay.
Or OpenAI's DistillBERT, which is this compact model that's distilled from a larger one called BERT.
Right.
These are showing us that you can achieve really impressive results without needing these huge amounts of computational muscle.
This is all super interesting.
Yeah.
But let's bring it back to our listeners for a minute.
Okay.
What does this shift towards smaller, more specialized models mean for the average person?
That's a great question.
Like, how is this going to affect them?
Well, I think it means that the AI that you encounter in your daily life is going to become more personalized and more efficient.
Okay.
So imagine interacting with several specialized AIs, each one fine-tuned for a specific task,
Okay.
instead of one giant generic model.
I see.
So think about your spam filter, your music recommendations, your navigation app.
Yeah.
All of these could be powered by smaller, more specialized AI models working behind the scenes.
So instead of having this one-size-fits-all AI,
Right.
we're moving towards something that's more tailored to our own individual needs.
Exactly.
That's really encouraging to hear.
Yeah.
It sounds like even though LLMs might be reaching a plateau in terms of just sheer size,
Yeah.
the potential for innovation and impact is far from over.
I agree. Yeah, it's been a really interesting conversation so far.
It really has. And today, I wanted to kind of shift gears a little bit
Okay.
and talk about something that's been on my mind this whole time.
Okay, what is it?
Well, we've talked about, the technical challenges and the economic challenges of building these massive LLMs.
Right.
But I keep coming back to this question, like, have we reached the limit
Oh.
with these models? Is this as good as it gets?
Right.
Or can they get even bigger and more powerful?
That's the question, isn't it?
It is.
And I think the answer is maybe a little bit of both.
Okay, how so?
Well, on the one hand, we are seeing those signs that the way we've been doing things, just scaling up,
Yeah.
is hitting a wall.
Okay.
The costs, the energy consumption, the difficulty of finding good training data,
Yeah.
it's all getting really hard.
So there are like practical limits to how big these models can get.
I think there are practical challenges, yeah.
Okay.
But on the other hand, you got to remember that AI is a rapidly evolving field.
That's true.
And what seems impossible today might be totally normal tomorrow.
Yeah, that's a good point.
There could be new breakthroughs in hardware, software training techniques
Right.
that push the boundaries even further than we can imagine right now.
So you're saying we shouldn't count out the possibility of even bigger, more powerful LLMs down the road?
I wouldn't rule it out entirely.
Oh.
Human ingenuity. We're pretty good at figuring things out.
That's true.
But I think we have to be realistic about the challenges and think about the trade-offs.
Okay.
If we just focus on making bigger and bigger models, we might miss out on these incredible opportunities in other areas,
Like what?
like specialization
Right.
and democratization.
Okay, so it sounds like the future of LLMs is not just one path, but kind of this branching network of possibilities.
I think that's a great way to put it.
Yeah.
We might see these superscalar models for certain tasks,
Mhm.
things like scientific discovery or really complex simulations,
Yeah.
where the scale is really important.
Makes sense.
But alongside those giants, I think we'll see this whole ecosystem of smaller, more efficient models
Yeah.
tailored for specific industries and applications.
So it's not one replacing the other.
Right,
It's
right.
more like a diversification of the AI landscape.
Exactly. It's about having the right tool for the right job.
I like it.
Whether it's a massive model tackling these huge problems
Yeah.
or a smaller one that's integrated into our everyday lives.
Well, this has been an amazing conversation.
Yeah, it has.
I've learned so much.
Me too.
And I'm sure our listeners are feeling the same way.
I hope so.
But unfortunately, that's all the time we have for today.
Okay.
So a big thank you to everyone for joining us for this deep dive into the future of large language models.
Yeah, thanks for listening, everybody.
And be sure to tune in tomorrow for a brand new episode of AI Podcast, where we'll continue to explore the fascinating world of AI. See you then.